What is up, my packet people? Hey, I am back with another Try Hack Me Room walkthrough. So, if you've been going through the SOC Analyst 1 path, you're going to notice that there's that network traffic or traffic analysis section, and in that section there's a few Wireshark rooms. So, in this video, we're going to cover the Wireshark Packet Operations room, which dives a little deeper into some of that functionality and also a bit more advanced into the filtering. So, let's go ahead and get to it. Okay, so here I am at the start of the room, the packet operations room. First thing I got to do in that first task is just to kick off that machine, get that started. So while that's warming up, we can take a look through this information, make sure we have a good understanding of how the room works, and just go ahead and make sure we don't lie, but we actually read the task above. Okay, so now that I've gotten into this room and the machine is started, now I can start up Wireshark. And I can open up that exercise file, and that's going to be where all of the questions are based from. So let's go ahead and get that going. All right, so now that I've got that virtual machine running, I've got Wireshark open, and now I have that exercise file loaded. Now I can go ahead and start off with task 2. So I know that I always just head check the number of packets in a PCAP, and I've got 81,530, just to get my head out of the way. You can see that as well. 81,530. So that just lets us know we're on the same packet page, or at least in a PCAP that has the same number of packets. So let's go ahead and open up this first one. So this is under the statistics menu. Now, one thing about this part of the task, basically what this is doing is just walking you through several of the features that you're going to see under statistics. All right, so let's go ahead and hit the statistics menu and see how we can answer these. So the first one, let's investigate the resolved addresses. What's the IP address of the host name that starts with BBC? Okay, so let's go ahead and hit to resolved addresses. And I'm just going to do a search for entry BBC. And here I've got an address there for me. So I can go ahead and punch that in over in my browser next door. And let's see if that's the correct answer. 24.81. Okay. All right, good. Whoop, whoop. Answer's correct. Okay, so there's that one. Now, what's the number of IPv4 conversations? So we're going to move away from resolved addresses now. We're going to go back to statistics menu, going to go down to conversations, and we want to take a look at the IPv4 menu. Don't even need to click at it to get the answer. Once all of them have finished processing, you can see that I've got 435. Let's punch that in, 435. All right, submit. Okay, good to go. Next, how many bytes were transferred from the micro ST MAC address? Transferred from that MAC address. Okay, so in this case, we're not asking for a conversation. We're not interested in who they're talking to, just how much did that one send. So that's going to pivot me. I'm going to close this. Now I'm going to be interested in statistics endpoints. Okay, so if I go ahead and let this load, it's going to load all of the unique stations that are transmitting, including the Ethernet stations. So I can come down here to name resolution. And if I come and I take a look for the micro ST right there, there it is. Now the number of transferred or transmitted. So in bytes, I've got 1083K. All right, that's how many it has sent out. So let's see if that's the right answer. All right, so 1083, and let's go submit. Oh, it's not right. So let's see what we did wrong here. Okay, so in endpoints, what I did is I went here and I first did the transmitted bytes, which is 1083K, which is accurate. But then I came over and I thought, well, what if it's asking about general bytes? This is both send and receive. So what I did is I just went ahead and punched in 7474, and then that worked. That was the correct answer. So this is actually an incorrectly asked question. How many were transferred from? This should say, the answer should either be 1083 or it should be sent or received from that MAC address. So just a note to the authors of the room. All right, so what's the number of IP addresses linked with Kansas City? So to get to that information, we're going to start to use the GeoIP stuff. So I'm going to actually come over here to IPv4, and I'm going to sort on city. And if we come down to Kansas City, I see I've got 1, 2, 3, 4 stations that are coming in from that address or are actually linked there. So that's where I can hit 4. Now, just a note, I'm going to be cleaning up a few errors that are actually in this room as we go forward and telling you about some of the things that I would actually do in the real world. Just so you know, the GeoIP information up here is not quite accurate. This GeoIP feature is not a native built-in part of Wireshark, meaning the option is there, but in order to get this working, you actually have to download and install the databases from MaxMind. Those are not built into Wireshark. So to show you how to do that, go ahead and hit a video up here. I have this on how to map IP addresses, and I show you where to go, how to download them, and how to point Wireshark to those databases, which has already been done on this machine. So they do save you from that headache, but just so you know, if you're ever working with Wireshark on your own system and you don't get the GeoIP location here working, that's why, because you need those databases downloaded and then point Wireshark to them. So just a note, okay? All right, so which IP address is linked with BlickNet? Autonomous System Organization. So let's go ahead and take a look at that. Now, if we just have to scoot to the right just a little bit over here, and this is where we can sort this Autonomous System Organization, and this is where I can just take a look for this one, and then I can come back over here, and there's my address. All right, now also I'm just doing this in the dialog for while I'm here for conversations or endpoints. But also, if I was out in the main part of the product, this is where I could make use of if I expand IP and come down to source and destination GeoIPs, this is where I could set filters for this stuff. So just so you know, I can come down to, for example, autonomous system number or autonomous system organization. I could have come up here, just pulled this up here, and then I can take a look at, if I want to just say contains, which we'll get to in a little bit. If you're just looking at a large data set and you just want to have a very specific filter, this is where I could say BlickNet. And then I could take a look at what matches that filter, only one packet, and then I can pull that address over. So 2 ways to look for it, either using the conversations dialog or setting a filter specifically for that autonomous system organization. All right, so that did that task, so let's go ahead and wrap that one up. So task number 2, and let's go ahead and expand out task 3 and get busy. Okay, so I'm going to remove my filter. Next, protocol details. All right, so let's dig a little bit deeper. Go ahead and poke through this and just take a read with it. So what's the most used IPv4 destination address? All right, so let's go ahead and take a look. Let's go to statistics. We're going to go to endpoints. And I'm going to go to IPv4, let that build out. And I'm actually going to sort on received packets. I want to see which one has received the most. And that's going to be this one up here, 10, 100, 133. Let's see if that's correct. Okay. All right. Whoop, whoop. What's the max service request response time of the DNS packets? Ooh, okay. A few ways to get this. Maximum service request response time. Okay, so I'm going to close this out. One way, I'm just going to show you. Do you want to see what I actually do or what I think this is going for? Okay, I wanted to show you what I actually do anyway. All right, so this is what I do. I go to dns.time. Now this is a filter that shows me, I'm just going to say greater than 0.100. All right. So this shows me all the DNS responses. And if I come down into the actual DNS responses, if I expand this out, let me come down to DNS. And you see time down here? Let me actually get my head out of the way. All right, time down here, I'm going to add time, right click, apply as column, and then I'm going to sort that column so you can see the slowest. That sort out for me. Jump down to the bottom. So this is the slowest response time down here, 467, 897. And if I look over here, that's the actual response time that the question is asking for. So what's the max service response time? So let me come over here. So 0.467, 897. All right, and if I hit submit, all right. So that's how I would actually do this question. Or if I was practically doing this in the real world, I want to see what are the slowest DNS response times. Well, actually, if this was a huge PCAP, I would actually take T-Shark and extract that value, and I would pull it out to the command line and then sort it, and then I would be able to see from the command line what the slowest ones are. But another way to do that is if I come into statistics and I go to DNS, here in this dialog, I'm going to be honest, I just forget that this is here sometimes. But if you come down here to request response time in seconds, it's going to show you the max value 467,897. It's that same value, and you can put that into the answer. Either one works. Your way or the highway when it comes to Wireshark. What's the best one that you would remember? Okay, just getting my head out of the way to make sure that you actually see that, the 467,897. Okay, so the next question, what's the number of HTTP requests accomplished by rad.msn.com? So since we're using the HTTP statistics menu, let's just stick with that. HTTP statistics, let's go down to HTTP, and let's go ahead and do requests. So here, let's let this build out, and after it's done, if we come down here to, let me just do a display filter, actually not a display filter. I want to come down here, it's gonna be, there we go. So rad.msn.com, we can see that there's a bunch of responses from this one. Now when I select this, I actually have to kind of arrow over here, and you'll notice way over here, so this is the total number count is 39 requests that were fulfilled by this server. So let's go ahead and see if that's the right answer. Answer format 39, let's go ahead and go to submit. And whoop whoop, that's our right answer. So, okay, so that gives us some comfort or practice with the statistics menu. Definitely something that you're gonna do when you're doing Wireshark analysis. Okay, next, let's go ahead and go to the next task that we have here, task number 4. Packet filtering. Wow, you're going to be doing a lot with filtering. So make sure that you read through this. Make sure that you have a good understanding about how operators work, logical expressions. You're going to need to know how you can set these up. I mean, filtering is a big part of what we do with Wireshark. So it's nice that this is a good cheat sheet for you to refer back to later on. I also have a Try Hack Me room that is very focused on Wireshark filters, so I suggest that you check that out. I have it linked down below. They don't have it public yet, but who knows, maybe one day. But anyway, yeah, make sure that you read through these, and let's go ahead and get some practice in actually using them. Okay, task 5. So here we are, task 5. So let me come down here. So what's the number of IP packets? Well, just very simple. We just type in IP, and that's going to give us the number of packets that have the IP protocol. So let's go ahead and come over here. The answer format, the number of displayed packets is, sorry, my head was in the way, 81420. Okay, so there we go. All right, next, what's the number of packets with a TTL value less than 10? Okay, so what would that be? Well, to find out the field, I mean, I know because I use it a lot, but IPTTL, but to find out that field, if you just select the IP header, and if you come down to the time to live, you notice down here in the lower left of Wireshark, you have IP.ttl. So if you're going to filter for that, for a value that is in that field, then you would use that syntax, IP.ttl. All right, so we need something that is less than 10. So we can use our less than, and then we can use the number 10, and then that's going to give us a result of 66. So there's only 66 packets that have less than 10. I'm going to, while I'm here, remove this time column. Okay, all right. So 66, that was our answer. Next, what is the number of packets that use TCP port 4444? So that's an easier one. TCP port filter, you're going to use these all the time. TCP port equals 4444. Now keep in mind, as well as equals, you could also say EQ. You can use the English equivalent here. Doesn't matter which you use, if whichever is better for you, either the symbol or the English equivalent. All right, so we have 632 packets, 632, good. Okay, so next, what is the number of HTTP GET requests sent to port 80? All right, so we're going to be combining filters here. So first thing we want to do is filter for all the GET requests. To do that, HTTP.request method. All right, so we'll first say that equals get. Let's test that first. All right, so that gives me all my gets. I'm going to put that in parentheses just to keep things nice and clean. And then I'm going to say, and the other part of this filter is it has to be to port 80. So TCP.port. And that's where I could say dest port to be very specific. DST port equals 80. Okay, so no 443s or other non-standard HTTP ports. That gives me a result of 527. So let's go ahead and hopefully you can see that. Get my head out of the way. All right, so 527. All right, so what is the number of type A DNS queries? Ooh, okay. So let's go ahead and get that one figured out. I'm going to come up here, going to remove this. All right, so first, type A DNS query. So that's going to be DNS. First, we can filter for DNS. Now, the DNS request is indicated by a flag. So if you can actually come down here, let me show where this is at. You see in the DNS flags right here, this is a response, the message is a response. We want a query. So we want to type 0. So DNS, I'm just looking down here, DNS.flags.response on the bottom. DNS.flags.response equals, well, if 1 is a response, then 0 would be a query. So this is just showing me all the queries that I have. And next, what I want to do is I want to add the type of query needs to be for a type A host address. Okay, so the query type should be 1. All right, so let's actually give this a shot. I'm actually going to take it right now. I'm actually grabbing and dragging this up to the top, and I'm going to say and selected. So keep the DNS.flags response, keep that there, and then add or append this this query or this type of query, the query type. I'm going to say and selected, and it's going to go ahead and do its thing. And I've got 55 packets. Let's just see if that's the right answer. I might have to do one more thing here. Nope, okay, it's incorrect. All right, so it could be that I have a couple other types that kind of snuck in there. So what I'm going to do is just head check. Let me just remove this. All right. Let me pull that out, back that out, get me my little packets back. I'm going to come up here to statistics just to head check this, come down to DNS. And you see the query type is, there we go, the A host address. Okay. So what's cool now is I can add a display filter to it. So I just want to see the packets, the number of type A DNS queries. Okay. So, and it's a 2-number answer format. Okay. So what we're going to do is we're going to do DNS.flags.response equals 0. Let's see what happens here. Okay, so now I've got the query type 51. All right, let's try that. 51. All right, that was it. So using the DNS menu under statistics and then adding that filter allowed us to go ahead and get that right answer. And I'm going to be honest with you, I'd have to dig a little bit further. Oh, we probably had a couple pointer records in there. I wonder, it's possible we had a type A and a pointer record in there, but they just wanted only the ones with an A record being done and no pointer record. Guessing that's what it was. Okay. So that was task 5. Let's go ahead and go on to task 6, advanced filtering. So there's a bunch of great stuff in here. This is where we learn about like contains and matches and the membership operator and a couple other string filters in here. So there's a ton of pretty good stuff here. I'm going to talk you through it, the stuff that I practically use as we go. All right, so first, find all Microsoft IIS servers. What's the number of packets that did not originate from port 80? Okay, so let's go ahead and do this. First, I'm just going to do http.server, and then I want to say contains. Let me do the quotation marks. So Microsoft. Okay. All right, so here's all of the servers. If I collapse IP, let me get my head out of the way, collapse IP, collapse TCP, and this is where if I come down to the server, you see here's Microsoft IIS. So this is going to have all of those servers there, this match that. However, not all of these responses come from port 80. So I want to say that did not originate. So I want to say show me contains Microsoft, and then I'm going to say and not TCP port equals 80. All right, so let's remove all the 80s. I've only got 21 packets that match that filter, so let's see if that's our answer. Should be. Whoop, whoop. Answer's correct. Fantastic. Okay, so find all of the servers. What is the number of packets that have version 7.5? Okay, so to do this, I'm actually going to do a little trick here. Oh man, I shouldn't have removed that. I just removed a filter that I want to bring back, so it's nice that I can have my drop down, right? And it remembers. so I can go ahead and just bring those responses back. So I'm going to come down here to the HTTP server again, Microsoft IIS. You see how this is like 6.0? I'm just going to take this and drag it upstairs, and I'm going to remove or replace that filter. I'm going to say selected, and now that brought the version with it. So now all I got to do is just say 7.5. Okay. All right, this is real talk. This is actually the kind of stuff that I would do out there in the real world. Okay, so displayed 71. So let me come over here, 71, submit. Okay, there was our answer. Now, what's the total number of packets that use ports 3333, 4444, 9999? Okay, so this is going to be a membership operator question. Anytime you have like a TCP ports, this, that, this, or a list, it's so much easier to do this with a membership operator. That's one way, right? There is another way to do it, but it's a long, crazy way. I don't even want to show you. All right, so let me go ahead and do TCP port in curly brace, and now I'm going to do 3333. Now here's what's tricky: 4444, 9999, and then close curly brace. You see how this is still red right now? Let me tell you a little something. Wireshark 4.0. The syntax that you see here works on any new version of Wireshark, okay? Because the syntax, they cleaned out some of the older syntax that they didn't like. This is an example of something they didn't like. Let me show you. You see if I remove these commas and I just put in a space between those numbers, it turns green. That's because on older versions of Wireshark, which is on this virtual machine, let me just go help about. Let me see here. What version we got here? Let's see here about Wireshark. Yeah, this is old. Version 3.2. Wow, this is a couple of years old. All right, so on older versions, this is, you got to have spaces in there. But as versions matured, you could start to have commas in there. Now with Wireshark version 4.0, spaces don't work. So if you tried this in the real world on your machine out there and you were troubleshooting, you would get no matches for this filter. Then it would actually be red. So I want to clean this up for you. I want to make sure you understand. In this context, on TryHackMe, for this answer, this is the correct syntax. But if you're out there in the real world, you got to have commas here. All right? So just you know, a word to those that'll be using Wireshark out there and practically in the real world, okay? All right, so over there on the displayed, let me actually apply this filter. So it's going to show all TCP traffic on any one of those ports, and I've got 2235, 2235. Cool. All right, there's our answer. What's the number of packets with even TTL numbers? Okay, I'm going to show you what this question is asking for, but there's a lot I don't like about this. First, yeah, I've never had to answer a question like this ever in the real world, ever. I mean, it's unusual that you would ever need to practically look for even TTL numbers. Maybe like a different field or variable, perhaps, but TTL is just kind of an odd one to ask for. What this is going for, I'm just going to sneak up here and I'll show you where you can get the cheat from it. It's basically this string filter right here. So what we're going to do is we're going to convert. I'm just going to copy this. You're going to, or you know, it's better to just type it in. Let's do string. So we're converting ip.ttl to a variable or to a string, and then I'm going to compare it. And the reason why I have to do this is because this is the only way that I can use a regular expression. Matches activates the regular expressions component, or allows us to do pro-compatible regular expressions with Wireshark. So the first thing I got to do, I can't just give it this field and not a number. I first convert to string, and then I say matches, and then I give it a bracket, and then I say 0, 2, 4, 6, 8, close bracket, and then I give it the $, and then close quotation. Now I just got that basically off this because in this case this was looking for find all frames with odd numbers. So to find all frames with even numbers, I just did the opposite numbers in here. I said basically start here 0, 2, 4, 6, 8, and then that $, basically is a continue to show me any IPTTL that matches this value. Now while I was looking at this earlier, it's actually kind of interesting because If I come in here in the answer format, let me just try the value that I got a result for, and that is 77 to 89. And let's see if that works. Yeah, okay, it does. All right. So that's the answer here. And again, back to practicality, I just don't see much of a use here in this specific field. Maybe another one, maybe a frame number, but again, not something super realistic out there for the real world. I just want to let you know. Okay, next, change the profile to checksum control. So right here, we're on the default profile. So I'm going to change over to checksum control. And let me tell you what they did for this profile. One of the things is they activated the ability for Wireshark to calculate checksums, IP checksums, TCP checksums, and UDP checksums. That's why you see these red bars here, and you got a lot more of these error level events, right? These are all like TCP checksum errors, IP checksum errors. So the question is asking you, what's the number of bad TCP checksum packets? So let me show you how I would filter for it. I would just expand out. Let me get my head out of the way. I would expand out TCP. I would come down to checksum, and I would come down here to the expert info, bad checksum, and you see tcp.checksum_bad.expert. So that's going to be a filter that we can set. Let me just bring that up here, and I'm going to go ahead and apply it. So 34,185 is the number of matches I got. 34,185. Submit, and that's the answer. Okay. How did that happen? Just so you know, if you right-click the TCP protocol and you go to protocol preferences, right here, all they did is they just did allow subdissector to reassemble TCP. Validate the TCP checksum if possible. By default, this is an unchecked value. Okay, and I want you to understand why. Basically, when you transmit a packet, sometimes Wireshark will capture that packet, the protocol driver will capture that packet before the TCP checksum gets validated. So any of your traffic going out from your system could have a false hit on a bad TCP checksum. It's only because we're capturing it too early. If we had captured it on the network, so off of a span port or a router or a firewall or off a tab, then the NIC, our network interface card, will fix that checksum before it goes out the door. So it's basically a false positive on an error event a lot of times when you have this active. So I want you to be aware of that. That's why it's disabled by default. But that's all they did for this profile. They just activated those bad checksums. Okay, so that was the answer to that question. So let's use the existing filtering button to filter the traffic. What's the number of displayed packets? Let's come up here. I'm just going to hit this display filter button. And here we've got 261 packets that made our filter 261. Bow. All right. So that brings us to the end of this room. Congratulations, you just finished this Try Hack Me room. All right, so I had fun with this room. I hope you did as well. Learned a little bit about Wireshark. Like I mentioned, there were a few things that we needed to correct, some errors here. Hopefully you understood that in the walkthrough. And go ahead and stay tuned for another Try Hack Me walkthrough with Wireshark right here on the channel. Take care, everybody.